So today we are going to start the next question from the exercise 2.7, sorry 7.1. The question number second we are going to consider from the chapter number 7, cubes and cube roots. Already we had discussed some properties. Again we had discussed the question number 1, in which we had obtained whether the given number is a perfect cube or not. And in same way now we have to solve the second question. So second question is like this: find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. That means the given number, 100% we can say that the given number is not a perfect cube, and we have to obtain one particular smallest multiplier by which uh, we can obtain the perfect cube number. How to obtain that perfect cube number now? By multiplying particular number, that smallest number we are going to obtain. Now here we are going to consider the example. The first example is 243. 243. Now we have to find out the perfect cube, that means by multiplying particular smallest number. And for that purpose, the first step is that in our solution we have to consider prime factorization of the given number, and that given number is 243. So here first of all we are going to obtain the prime factorization of 243. Then only it is possible to find the smallest number by which we are going to multiply. So therefore we have to consider the prime factors of 243. So for that purpose we are going to divide by some prime factors to that number 243. And we know that if the given number is even number, then we are multiplying it by 2, and if the given number is odd number, then we are dividing it by 3. So here if we observe the given number 243, then clearly we can say that it is an odd number. So therefore we have to divide it by 3. We are going to divide it by 3. So first thing is that we have to find out whether this number is divisible by 3 or not. If it is not divisible by 3, then we have to move to the next prime factor, which is 5. So therefore first of all we are going to divide it by 3. So we all know that 3 8s are 24. So here we are going to use the first prime factor as a 3. So we all know that 3 8s are 24, and here remaining 3 is there. So 3 1s are 3. So therefore it is perfectly divisible. After dividing by 3 to the number 243, we are getting the answer as 81. We are getting answer as 81. Now again you have to observe that number 81, whether it is odd number or even number. So here it is clearly, you can see that it is an odd number. It is a odd number. So therefore we are going to divide it by again 3. Again we are going to divide it by 3. So we know that 27 3 is a 81. If you know the 27's table, then we can say that 27 3 is a 81. So therefore second prime factor is 3, because it is perfectly divisible. Now you all know that if we consider 3's table, can 27 is divisible by 3? You have to think about that. Yes, obviously it is divisible by 3, because 9 7s are 3. Sorry, 3 9s are 27. 3 9s are 27. So therefore we obtain 9. Again 9 is divisible by 3. 3 3s are 9, and this last 3 again it is divisible by 3, and after dividing that 3 by 3 we are getting the remainder as 1. So we know that up to when we have to continue that prime factors, when remainder is 1, then we have to stop. So here remainder is 1, so we have to stop here. So we obtained our prime factors. So now just you have to observe how many prime factors are there. So here if we consider only one prime factor is there, which is 3. only one prime factor is there, which is 3, and we have to now observe how many times that 3 is repeated. So if we express that 243 in the prime factors, then it is clear that it is observed how many times? It is observed 5 times. It is observed 5 times. And if we want to form the triplets, triplets means each prime factor should be repeated 3 times. So that means if we consider pair of 3, then the first pair is formed 3 into 3 into 3. So that is referred as a triplet. But remaining 3 cannot able to form the triplet. They are not able to form the triplets because remaining 3 are only 2 in number. That means they are repeated only twice. They are not repeating thrice. But in order to consider the perfect cube number, each prime factor should be formed triplet. So here that condition is not satisfying. So therefore, if we consider the conclusion, here we can say that 2 threes are left which are not in a triplet. That means they are not forming an triplet. So therefore, to make 243 as a cube number, one more 3 is required. What is required? One more 3 is required. That means we are going to multiply by 3 to these prime factors. We are going to multiply by 3 to these prime factors. So here we already performed operation method in equations, and you know that if we are going to use any operation, then we have to perform that operation on both the sides. So here in order to form the triplet, we are going to multiply this RHS by 3. So in same way we are going to multiply by 3 to the LHS also, because same operation should be performed on both sides. So therefore, after multiplying by 3, we are getting, so in that case what we are getting then, 243 into 3. That means we are going to multiply by 3 on both sides in order to form an triplet. Then RHS will become like this, 3 into 3 into 3, which is one form of triplet. Then second triplet is again 3 into 3 into 3, and after performing all the multiplications, that means 243 into 3, by performing this multiplication, we are getting that number as 729, which is referred as a perfect cube. So therefore, in conclusions, we can write down the smallest natural number by which 243 should be multiplied to make it a perfect cube is 3. So by which smallest number we are going to multiply? By 3 we are going to multiply. Then 243 is going to converted into perfect cube. So in this way we can solve such a type of examples where we can obtain the smallest number by which we can multiply the given number, so we obtain perfect cube. In second example, the example is 256. Actually this 256 is a perfect square number, but it is not a perfect cube. It is not a perfect cube because according to our question, we have to find out one particular smallest number by which we can multiply this particular number. That means it is clear that given number is not a perfect cube. So that means 256 is not a perfect cube, and we are going to obtain the prime factors of this 256. So here the first step is again same. So firstly, we are going to obtain the prime factors of 256, and in order to obtain the prime factors of 256, we have to divide it by either 2 or 3, and it totally depends on that number. If the given number is even, then we are dividing by 2. If given number is odd, then we are dividing by 3. So here just observe the number 256, and by observing that number, it is clear that the given number is a even number. The given number is a even number. So that means here we are going to divide it by 2. We are going to divide it by 2. So therefore, after dividing it by 2, we are getting the quotient as 128. 128. Now again observe the given number, whether it is even or odd. Which number now you have to observe? You have to observe this 122, which is odd or even, that you have to observe. So again we can say that 128 is an even number. So therefore we are going to divide it by 2. We are going to divide it by 2. So therefore, after dividing it by 2, we are getting 64. We are getting 64. Again observe the next number, which is odd or even. Again we can say that 64 is an even number. So again divide it by 2. So we know that 64 divided by 2 is going to be 32. Again, which is an even number. So again we are going to divide it by 2. So we know that 16 2s are 32. Then again divide it by 2. Then 8 2s are 62. Sorry, 8 2s are 16. Then 4 2s are 8. Then 2 2s are 4. And last one, 2 1s are 2. That means we are dividing it by 2. Then we are getting the remainder as 1. So here the remainder is 1. That means our prime factorization is completed. As the last remainder is 1, then the prime factorization method is completed. So therefore, here again only one prime factor is obtained, which is 2. Again, if you observe that prime factors very properly, then we found that only one prime factor is there, and that repeated so many times, and that prime factor is 2. So if we take proper multiplication of those prime factors, then we are going to write it like this: 256, which is equals to 2 into 2 into 2 into 2 into 2 into 2 into 2. So 8 times that 2 is there. So if we count it very carefully, then how many 2's are there? Total 8 number of 2's are there. Total 8 number of 2's are there. And now we have to divide them into triplets. We have to divide them into triplets. So therefore, first triplet, we can able to form the first triplet. Now we are going to try second triplet. So that second triplet is also possible. But now we cannot form the third triplet. Which triplet is not obtained? The third triplet is incomplete. And in that third triplet, the prime factor is 2. The prime factor is 2. So therefore, here 2 2's are left which are not in a triplet. So how many 2's are there? Total 2 2's are there which are unpaired. That means they are not forming the pair of 3. Pair of 3. So therefore, to make 256 a cube, one more 2 is required. How many 2's are required? Another 1 2 is required. Now in case of first example, only 1 3 is required. Here 1 2 is required. So therefore, multiplying it on both the sides, 256 into 2, which is 512, and remaining factors will be as it is by adding another 1 2. So here you can see that they forming the triplet. First triplet, sorry, first triplet, then second triplet, and then here third triplet. Now all the triplets are there. So therefore, the given number 512 is a perfect cube. And how we had taken this 512? we had taken this 512 because we had taken the multiplication of 256 into 2, and that multiplication is 512. 512. So in this way we can able to solve the uh, given question, and we can write down the final statement like this: the smallest natural number by which 256 should be multiplied to make a perfect cube is 2. So we are going to multiply it by 2, then we are getting the perfect cube number, and that perfect cube number is 512. That perfect cube number is 512. So in this way we can able to solve the examples in which we are finding the smallest number by which following number should be multiplied to obtain a perfect